So when I gave you a point that's on the unit circle, that's assuming that the circle is one of radius of 1, and I gave you one of these points around the circle, right?
Yeah.
But now I'm giving you points that can be anywhere. Like let's say the unit circle's here, it could be out here. We can still draw the triangle that's associated with it, and the angle that comes out of it is still a fraction of 360 degrees. So we can still find the angle. So it's a little different what we're going to do to find it, but it's doing the same information that you already know. Like you know everything you need to know. I just need to show you what I'm talking about. First thing I'm going to do is I'm going to draw a triangle where I connect the terminal side of the angle to the x-axis. Do not do it to the y-axis or you're going to be in a heap of trouble. Theta always comes out of the center. And the point is root 19, so that's the x that goes here. And the negative 9 goes here because you go right root 19 and down 9. And they want secant of theta. So we know that secant of theta is the reciprocal of cosine of theta. So we know we're going to need the hypotenuse. So let's go ahead and do that. Root 19 squared plus negative 9 in parentheses squared equals c squared. And you're going to leave it in radical form. So this is going to be 19 plus 81 equals c squared. That's 100 equals c squared. And c equals 10. You can see that's not on the unit circle. If this point was on the unit circle, your hypotenuse would have been 1. The cosine of theta is root 19 over 10, and all students take calculus. So cosine would be positive. Everybody get that? Then the secant of theta would be 10 over root 19. And we've got to get the radical out of the basement. And we get 10 root 19 over 19. And we know it's also positive because the cousins are the same sign as the originals. So here is my triangle. I put a line up to the x-axis. Theta is coming out of the center. Negative 2 root 5 is right there. And negative 4 is here because you know that the third quadrant is negative, negative. So we got to find a tangent. Now in this case, do I have to find the hypotenuse? I don't need to find the hypotenuse here. So tangent is TOA. So it's going to be opposite over adjacent. And I'm going to clean that up a little bit before I get the radical out of the basement. And I'm going to get 2 over root 5 because negative 4 over negative 2 is 2. Everybody get that? All right, so now we got to get the radical out of the basement. And we get that it's 2 root 5 over 5. And all students take calculus. So they want tangent, and tangent is positive. So that should be your answer to number 2. So if the point on the circle is negative 9, 13, not on the unit circle, but on a circle, I need to find the cosecant. That means I need to find the sine and flip it upside down. So if sine is opposite over hypotenuse, so SOHCAHTOA, cosecant is the reciprocal of that. SOHCAHTOA, sine of an angle is opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. So they're cut. So when I find the hypotenuse, I get 250 equals c squared. 250 is not a perfect square, so I've got to factor 250 and see if anything comes out of the hood. And I get 5 times 5 times 5 times 2. And if you did a factor tree, that's what you would get. So I can pull out 1 5, and what's left under the hood is a 10. So the hypotenuse is 5 root 10. We've got to go back to where the cosecant is. Cosecant is hypotenuse, 5 root 10, over opposite, over 13. So that's the answer. Now we have to decide if it's negative or positive. Is the sign positive in the second quadrant? All students, right? So that means the cosecant's positive.